In this video, we will use web scraping to figure out who's the most popular Avenger in the Marvel universe. Additionally to the tutorials in the previous lecture, I wanted to give you an extra example of web scraping where I scrape Wikipedia. Why? Because Wikipedia is easy to scrape, it has a lot of interesting and useful information, and just in general, it's the most popular website that beginner data scientists like to test for these sort of projects. So without further ado, let's dig in. First, about the concept. There is a heuristic. Unfortunately, I don't know the source, but if I find it, I will link to this lecture. But the heuristic says that the more information a person has on their Wikipedia page, the more popular the person is. I'm not sure whether it ever has been statistically proven, but for now, let's accept it as the starting point of our project. I will use this heuristic to figure out who's the most popular Avenger out of these four well-known characters: Iron Man, Thor, Hulk, and Captain America. Okay, so we will scrape Wikipedia, and for that I will need a Jupyter notebook open, it's right here, and Wikipedia open, it's here. And the first thing that I will do, as always, I will go ahead and import the libraries that I need. Let me just zoom in a little bit. And you can copy this from the web scraping tutorials on Data36 from BS4 import BeautifulSoup SBS and import requests as well. Hit enter and we have the libraries we need. The second step is to find the URLs for the web pages we want to scrape, and so I have already opened the Iron Man article. We will need this URL. I will just copy paste that here, and then I will need, of course, the Hulk article. Copy and paste. Captain America. Looks good. And Thor. This is not the Thor we need. We need Thor from Marvel Comics. Okay, this one is it. And so with a few searches, we will end up with this list. Make this more Python friendly. So I put them between apostrophes, and you can put this into an actual Python list because probably we will have to iterate through these URLs soon, but I will get back to that anyway. So turn this into a list and save it to, I don't know, characters for now. Great. If you read the first BeautifulSoup tutorial that I linked in the tutorials lecture in this module, you will know that scraping a web page is just a few lines of code. All you need is the URL, and let's take Iron Man as an example. Nice. Then you need to run a requests.get function for this URL, and it looks like this: requests.get URL, and let's save this to the response variable. And then you need to store the content part of the response variable that you have just created in the previous step into another variable. Let's call this HTML. I rerun this cell every time when I add a new line to check whether I made a mistake. In that case, obviously, I will get an error, but so far it looks good. And so the next step is to use the BeautifulSoup module that we have imported as BS at the very beginning of this Jupyter notebook, and put here the HTML variable that we have defined in the previous line, and then store this into soup. And again, this is a super standard process. I just copied this from the BeautifulSoup tutorial article, and you could put here literally any standard HTML website's URLs, and this would just work. And so I won't go deeper into what these lines mean. If you want to go deeper, just check out the tutorial. And for now, let's take a moment and check out what we have so far in the soup variable. I mean, you can check out the variables for each step by yourself, but this soup variable is where it gets exciting. And if you print this variable, you will see the full HTML code of the website. And that's just perfect. This is what we need. Now it's time to parse this data. We can extract all headlines from this HTML content, for instance, and the main headlines on a standard HTML website are referred to as H1. Here it is. You can even check that out if you go to the website, right-click, inspect. There is our H1 header. This is the same line that we had here. And so I will type soup find all H1. See, that's the main title of the article. Iron Man, of course. Oops, that's Thor, but let's check out the Iron Man article. So here, this is the H1 line. H1, Iron Man, cool. Just what we needed. We can do subheadlines. So, for instance, this must be an H2. Yeah, there it is. This is an H2. Let's scroll down a little bit. This is an H2 as well. Let's find these lines. All I have to do is replacing H1 with H2. See, the same lines show up. Publication history, fictional character biography, and so on. And of course, you can do this with H3, H4, and so on to find all the titles and subtitles. I will just zoom in a little bit more. Okay. And so the problem is that this is a slightly ugly format. So as a final step, let's make this prettier. I'm still following step by step the article tutorial here. I will just iterate through all the headlines and run the getText function on them. I will save this into a variable called allH2, and I will do for H2 in allH2 print H2 getText. This is the getText function that makes stuff prettier. Strip text. Oh shoot, it's not text, it's true. Sorry. Okay, here we go. This is what I wanted to see. All the H2 headlines in a nice format. Well, not exactly what I wanted to see, because I want to count the words on this web page. More specifically, count the words in the flowing text part. So here, for instance, well, for the whole page, of course. And these flowing text parts are stored under another HTML parameter. As you can see, I will do inspect here as well. It's the P parameter. And go back and let's do that. So I will change all H2 to all P. And for P in all P get text. Cool. This is all the text from the Iron Man Wikipedia page. Well, except headlines and a few other types of special elements like bullet points and whatnot. But we are not done yet. Remember that I said in the intro video of this module that all web scraping projects will need some creative problem solving, especially when it comes to data cleaning. Well, even this simple Wikipedia example comes with issues as well. The most annoying issue is that everywhere where you see links on the Wikipedia page, we don't see the space characters in the script version. Take this as an example. The problem is that if we want to count the words on the web page, we will mistakenly count 1 instead of 3 for every link we have on this page, right? Without the spaces, this counts as 1 word, although it's 3 in reality. We can check this out on the web page as well. Here, this is the part that I'm talking about. 3 words, 1 word, not good. And as you can see, we have quite a few of these. Yeah, Wikipedia comes with a lot of URLs and links. So that's not good. It will definitely skew our analysis. We will have to fix this, and I will show you how to crack this one, but the real point here is the process rather than the exact solution. Okay, so the first step is that we want to find what causes the problem. The most logical thing is that the issue happens somewhere between these and these steps. I suspect that the web page content has been downloaded correctly, but the parsing by BeautifulSoup failed somewhere. So let's get back to the soup object and examine it a bit more. I will print soup and see our HTML content. And let's scroll down to the section where we found the problem. I will just search for it. Okay, let's try this. The character was co-created. There you go. And let's see the issue. Okay, this is the raw HTML content. This is the parsed version. And indeed, in the HTML content, everything seems to be correct. So my suspicion is that any text on this page that has these HTML tags around, for instance, the superhero word, either link or a bold character or anything, there the spaces are removed by BeautifulSoup. Okay, if that's true, then this should be an issue as well. Okay, and it is. I hadn't realized this at first sight. No problem, I think there is an easy fix for this one, and I say let's try to add an extra separator between all words in this text. There is a parameter for that in BeautifulSoup, so you can just add here a parameter. And full disclosure, I didn't know that either. I looked it up in the BeautifulSoup documentation when I created this project, and that's totally fine. It's fine to look up stuff in documentations, in hobby projects. Just to let you know, it looks like this. Separator is a space. Let's see. And boom. Our issue is solved, just like that. It's not perfect. The main issue is solved, but there are some other smaller issues that we won't solve here. If you want to, you can, but this would make this video super long, and honestly, they are very easy problems to solve. And on the top of everything, even if you won't solve them, we will get an around 98% accuracy. That's good enough for me. Just in case, I will get back to these issues soon and list them. But first, I will finish this analysis and show you the results. So, as you know, our end goal is to count the words in this text. It will be fairly easy. It requires only 2 simple Python functions. First, we will need an extra split function here that will split our paragraphs into lists of words, and then we will go ahead and count all the elements in this list one by one. That's what we have the len function for. Nice. These are the number of words by paragraphs in this text. And eventually we will add up these numbers with this old school Python solution. Full content length is 0. We will store this value into something like paragraph length. So basically in every iteration we store these values into this variable, and then we will add this variable to the full content length number, and basically this will just go ahead and add up all these numbers. Let's see. Done. I think this is the number of words in the paragraphs of the Iron Man Wikipedia article. And we are almost done here. At least we have done the hardest part of the job so far. So we have scraped one article, we extracted the data we need, we counted the words, and we have the number of words in the Iron Man Wikipedia article, which is a little bit more than 16,000. And I promised to list the known issues with this solution, so here they are. As an extra task, you can go ahead and figure out how to solve them. First, let me scroll up a bit, or I will just show you this. So the first problem is that punctuation should be removed for higher accuracy. Also, as you remember, headlines are excluded from this analysis. You can bring them back for higher accuracy. And special elements like tables or bullet lists are also removed. You can bring these back for higher accuracy. And probably you could remove or bring back a lot of other things, but again, I tested it, and not having these in our analysis doesn't make a big difference in the results, mostly because these inaccuracies are equally represented in all 4 Wikipedia articles that we examine in this project, so I didn't want to take your time with them. Speaking of which, let's move on to the last part, getting these counted word values for all 4 Avengers. And we will do that by putting this whole thing that we have written into one big for loop. Let me just do that. I won't need this soup parameter. I will copy paste this here. I can remove this. I will do this print full length. I won't need this one either. Okay, basically this is our script that we have written so far. Let me just rerun it and see whether it works. It's still working. The only trick that we will do, and this should be pretty basic for anyone who uses Python, like on a basic level really, we will put this whole thing into a for loop and we will iterate through the previously created characters list, and the URL should be obviously not this specific Iron Man article, but the given element of the loop. And let's check it out. There you go. Obviously, you can make this nicer and put the URL next. Actually, I will do that. I can put the URL next to the counted values. And of course, you can do bar charts in Matplotlib and everything else. But based on what we have created, Iron Man is the most popular Avenger, Captain America is second, then Hulk, then Thor. And I know this was a silly example of using web scraping, but I do hope that you still learned a lot from it and that you will be inspired by it and will figure out something more exciting to scrape and analyze on Wikipedia by yourself. As I said at the beginning of the whole module, web scraping is not too hard once you know the basics. It seems scary at first, but realize that this simple analysis took no more than a few lines of Python code. Basically, we have imported the modules, then we have downloaded the website content, then we pretty printed it and counted the words, and then we iterated through the different URLs with a for loop, but the whole thing is like 10 lines of Python code. Anyways, this is it. Now it's time to start your own web scraping project.